Right then, we've got the three samples of sand here, slightly different weights of sand, so they've been dried out completely. And what we found was that the percentage of water in the sand as supplied in the samples was 5% in sample 1, 24% in sample 2, and 13% in sample 3. That's the percentage of the dry weight of the sand. So what I'm going to do is add some water, 10% of the weight of the sand in water, which isn't an awful lot of water, as you can see, and that's 10% for sample 1, and just see how it makes the sand behave. You can see at the moment we've got dry sand in all of these samples. They feel similar. This actually does feel and look finer in sample 2 there. Sample 3 looks similar to sample 2. Sample 1 you can see is visibly coarser. But they behave very similarly. It's rather like the sand you would get on a sand dune when you run up the sand. The finer stuff seems to run through your fingers perhaps a little bit easier, but it's very hard to tell any difference between them. So we'll add 10% water to all of these samples and give them a bit of a mix and see what happens. Okay, so that's 10%. As you can see, it in no way soaks the whole sand, so we'll stir that in now and see how that makes the sand behave. So this sand then is nowhere near saturated at the moment, but sample 1 does contain more water now than the sample as supplied on the track, so roughly twice as much water. Okay, let's just clean the spoon. Okay, so that's sample 1. Sample 2, we'll stir that in. I think the most obvious thing to say is that there is a big difference in the behaviour of the sand, even only adding 10% of water to it. And it shows that when you're looking at the quality of the surface of a track, you're thinking as much about water as you are about sand. Okay, that's sample 2. Sample 3 then. Stir that in. Okay. Right then. So let's just see if we can feel any difference in how those sands behave now we've added the water there. 10% in each one, don't forget, this is still quite crumbly. Breaks up very easily. You can't compact it down easily into a hard sand, I don't think. Let's just try that now. No, I don't think that's going to make into a hard surface at all. Hard to tell with a small amount like this, but it's certainly got a lot of give in it. Let's try sample 2. Try not to cross mix them. Okay. Let's see how sample 2 behaves. Quite different from the dry sand, as I say. You'd probably better get that, compact that down into a fairly hard surface, I would imagine. Still quite crumbly though. Okay, and sample 3. Again, that should compact down quite well, I would have thought. Oh, there again, it's actually quite a bit crumbly now. You come to hold it in your hand and test that. Let's just try 2 again. 2 certainly feels a lot softer now it's wet. Down to get a little bit of mixing of sand, which isn't ideal because we have some other things to do with this sand. Certainly 1 is the most obvious one that you can't get to fall into a ball in your hand there. So there is a bit of a difference in the behaviour. So what we'll do now is we'll allow these samples to dry out again, reweigh them because the weight will have changed slightly where we've spilt some of the sand. And the next thing we're going to do is see how much water the sand will hold when it's at maximum saturation. So to do that, we'll add water until the sand is completely saturated and won't hold any more water, and see how much water each sand holds at that point. Okay, that's coming up next.